Okay, so we do a bit of revision of what we have learned in chapter 1. So it's all about variation. So variation means relation, hubungan. So we have two types of relation here. The first one is direct variation. So direct means if one is increased, one variable is increased, another one is also increased. So we can look at the graph there. So the straight line represents the rate at the same rate. So one increase, another variable also increase at the same rate. So that's what we call direct variation. Inverse is the balik, opposite. So if x increase, then y decrease. So you have inverse variation. So if we show up on the graph relating x and y only, so the curved line will moving downwards, showing inverse relation. However, the inverse relation also increase or decrease at the same rate. Hence, we can convert it into y vs 1 over x. Say over here is 1 over x. Okay, so that's how we there are two types of variation. So if we combine, then we call it combined variation or joint variation. Okay, so I think we have stopped somewhere. So we'll just continue the exercise here from Terengganu one. Okay, so number 7. So the time taken, T hours, to arrange chairs in the hall varies directly as the number of chairs n. So that's how we find out all the keywords. And inversely as the number of workers, P. Full stop. So that means from the first sentence, we already have the info of the relation. So we can change it into variation form first, which is T varies directly as the number of chairs and inversely as the number of workers, T. So that's from the first sentence. So given that 6 workers, okay, 6 workers means P equal to 6, T equal to 2 hours, and arrange 800 chairs. So chairs means N equal to 800. So A express T in terms of N and P. So meaning we change it into equation form. T equal to K N over P. Then we substitute all the numbers to find out the value of K lah. So T is 2 equal to K times N over P. Okay. Then we can find out the value of K. So K is on the right side. So 2 times 6 over 800. So we get the value of K is 3 over 200. But that's not the N yet. So we have to write back T in terms of N and P. So T equal to 3 over 200. Okay, then N over P. So we can just proceed to write at the back. And we managed to get the answer. Okay, so that's the answer for A. So next question will be easier because it just need to substitute and find out the variables only. So B, hence calculate the number of chairs. So find out the number of N that can be arranged in 1.5 hours if the number of workers are 12 people. So P equal to 12. So we just need to substitute 1.5 equal to 3 over 200. So N at the back, we want to find. So 200 times PP is 12. So again, we can find out the value of N already. So the most important, you have to show up the equation. Yeah, the calculation is not that important, but how you find the answer, the working is important together with the answer lah. And the last question, C, if the number of workers increases. So number of worker means P, what will happen to the time needed? So if you look at the variation form, if P increase, so what happened to T? Since they have, yes, you're right, decreases, right? Because they have inverse variation. Yep. So time decreases or time is lesser. Time needed is lesser, also can, as long as you can explain. Okay, and we complete and we get 5 marks in total. So this type of questions in chapter 1 is not that hard. Huh? Okay, so shall we proceed? Can. All right, thank you. Okay, so next questions almost similar. It's the same. Let me see this one. Is there any key but? Okay, almost the same, right? So we just change only. You prefer me to give you the answer? Have you tried? Or you want me to just write down the working? Okay, okay, sure, sure. Okay, you can try. Yep. So same thing, we write down the variation form. T varies directly as the number of seat x over y. So change to equation form, kx over y. So he hire 4 employees, so 4 employees. So would be 2 equal to k times 200 over 4. So you will get your k equal to 1 over 25. Is it same answer? K equal to 1 over 25? Okay. So since now it's 1 over 25, you want to write in equation form. So we can change it to decimal, 0.04. So t equal to 0.04x over y. So calculate the number of employees needed to arrange 200 seats. Okay, so T is 1. So K is 0.04 X over Y. So change only. So you get 8. Yes, you got it correctly. Well done. Congratulate. Okay. So it seems like chapter 1 is quite easy, not that hard, right? Okay, then we have objective here. Okay, few more questions on it. I think, yeah, we can just go through a quick one. So given R varies inversely as the cube root of S. Okay, so same thing, R varies inversely as the cube root, so that is S. So change to equation form and substitute, right? So R is 4, S is 27, cube root of 27 is actually 3, right? So K equal to, this is 3, so times 4 is 12. So we get K equal to 12. So change this to 12 and we get the answer. That do right. So objective, usually we can use cancellation method. Cancellation method means those impossible one you can cancel out to get the correct answer. Okay, and the second question is from SVP. Okay, so this is this year state trial paper. Okay, when there is a table, so how we read the value of the table goes by column log, by column. Meaning when W is 20, R is 30, and T is 0.75. So same thing. If let's say you want to key in calculator, okay, so now we are using calculator. There is a button. Okay, we do one by one. Can I know which mode of calculator that you are using? Is it Casio 570ES, EX, or MX? Since they've got ABC one, is it? Got ABC one. Yeah, this one. Or like this. EX, okay, okay. All right, can. No problem. Okay, so we continue with this one first. We just write down the variation first. W varies directly. If you want to change the equation form, now can be faster already. Equal to KR and inversely with the square of T. So T square. Okay, so straight away, we can write down the equation form already. So to find the value of K, substitute 20 K R T square. Square 2. Okay, so K, bring down the K. So if there's a fraction at the back, we move to the other side, then we just flip over. Meaning 20 times 0.75 square over 30. So straight away, we will find the value of K. So we get 3 over 8. If you want to change to decimal also can. 0.375. Okay, so dot dot dot. W equal to 0.375 R over T square. So to proceed to find X, which is equivalent to R, very simple only. So just substitute. Then we get the value of X. So what is your value of X? 125. Okay, correct. Yes. Perfectly done. Yeah, it's perfectly done. So Terengganu also is from is in table form. Similar. Okay, why not? I just leave it. Okay, 1 minute. We try to get the answer. Okay, so we are now trying questions 18. Okay, so it's from the last 2 weeks questions. Yeah. 3 over 2, but it seems that there's no answer 3 over 2. Perhaps it's the calculation. Okay, so let's double check. It's given that y varies inversely as the square. Inversely must go down. Inversely square of x. Change to equation form y equal to k over x squared. So goes by column. Yeah. So find out the value of k first. So y is 1 over 2 equal to k over x squared means 9. So k equal to, so I just write here. So 9 over 2, right? So dot dot dot. Now we want to find value of m, which is equal to x also. Y equal to 9 over 2 over m squared. Because x is m. So change place. Okay, so it will be square root of 9 over 4 kan? Oh, 3 over 2 eh? Then that's the answer. Okay, my bad. I can't see it. Yeah, 3 over 2, yeah. Okay. Alright, your answer is correct just now, Haris. Okay. Okay. So you got the answer. Okay, and then the next one, last one, 19, before we move on to chapter 2. So the last question. So we can do together. So a simple one. So it's given that q varies directly as the square root of x and varies inversely as the cube of y. So we just write it in equation form. Square root of x and inversely as the cube of y. So y power to 3. So if q given, okay, it's written like this. What does this mean? It changed it to indices form. So now it relates a little bit knowledge about indices form. So if it's square root, if you change to indices form, it will be power to what? This one is indices form already. One over two. Yeah, power 1 over 2. Yeah, indices form. Okay, so this one no problem now. Y cube now. So what is the value of A and B? You got the answer. Yeah, so sometimes they would relate a little bit with other chapters, other topics like indices. Yeah, so we can see. But the variation is very simple and direct. Okay, still got one. Oh, still got 2 there. Okay, so I think this one, I just give you answer lah. It's pretty easy. I think we can start chapter 2 directly. We can start chapter 2 directly since we have this one class last week. Okay, so that's about variation. It's pretty easy. So chapter 2. Let's move on to chapter 2. Yeah, let me just for a while or waiting for Sarah. Yeah. Okay, we are just about to start chapter 2 matrices. Okay, this chapter is quite fun if you like this chapter. Okay, if you like this chapter. But usually this chapter is very popular lah. In every year it will come out, no matter it's in objective or in paper 2. Paper 1, paper 2, for sure it will come out one. Last time KBSM is every year, surely it will come out in paper 2, and it's like a bonus. Also, students like this chapter because it's predictable. Okay, predictable. Okay, so let's talk about matrices. So matrices is about a group, like a group, so you will give it a name. So if some of you are studying ASK last time, I'm not sure. Any one of you studying ASK or not, like the coding one? Got it? Yes, right? Okay, so like the coding one. So if you want to insert the coding, so some of the numbers you cannot insert until 11, 12, like 2 digits, no. So it may be from 0 to 4, so it's in a group, so we call it matrices. Okay, so matrices consist of rows and columns. Okay, the row means like horizontal, like this got two rows. Vertical means column, so got 2 columns, 3 columns, columns vertical. Yeah, row is horizontal. The arrangement. So the arrangement of this matrix, arrangement in math, we call it order. So the order of a matrix is determined by the number of rows and columns. So as you can see here, this is 2 by 2. 2 by 2 means 2 rows, 2 columns. So if I write the matrix form in this way, how many rows and how many columns? How many rows and how many columns on the right side? 1 row, 3 columns. So when you want to write the order, we have to write 1 by 3, 1 times 3. 1 row, 3 columns. 1 row, 3 columns. So read like this. Okay. So another example here, the order is 2 times 3 because 2 rows, 3 columns. So first we have to know how to read the order first. Okay. Then each of the element means the member inside the matrix, the group. The element got name 1. Okay, so the name is according to the position. Example, same thing here. So I will write E. E stands for element. So this element situated at the first row, first column. So E11. Digit 2 will be first row, second column. So E12. So this is E13, the third column. Then the second row, first column. So E21, E22, E23. You need to know the position also of each of the element, because sometimes they will ask a very simple questions. What is the sum of E11 plus E13? And then you have to take the number law. You have to know where is the position. So 1 plus 3 is 4. Just simple like that. But first, you must know the position. Okay. Any questions about the position, the order, the matrix? No, right? All good, Can do, Okay, so why not we try this? So 5, -5, 2, 3, 1, 7, -2, -3, and -1. Okay, can you tell me which digit is situated at E31? E31 means third row, first column. -2, correct. Okay, so third row, first column. Okay, what about E31 minus E13? Is it 0? Okay, change answer. Okay, so must know the element first, right? So -2 minus E13 is +2, right? So answer is -4, yeah? Yeah, correct, -4. Yep. Okay, so So that's how you write accordingly. Then only we do the subtraction, addition or subtraction. So that is the element. Very clear. I think all of you can do. So next, after we know all about the element, the name, the order, now we can do equal matrix. Look at the word equal. Equal means exactly the same, exactly the same. So equal matrix will have same order. Make sense, Okay, so look at the first bracket here. This is 1 times 2, right? 1 row, 2 column. On the right side also, 1 times 2. So when these two matrices are equal, you can find the elements already, the value of P and Q. So we can form equation. Okay, we can form equation here. 4P is equal to 12. So P equal to 12 divided by 4 is 3. Next, because it's equal matrices, so 8 equal to 10 minus Q. We cannot say it's a group, it's an element. Group means matrix. This is a matrix. It's a group lah, okay? It's a term, it's a term. Yeah, it will be better we can use term. Okay, so Q equal to 10 minus 8, so Q is 2. Equal matrix means this element same as this. So if you write out E11, this is also E11. Then this is E12. So this whole thing, this whole term, E12. Okay, so equal matrix. Very simple, only equal matrix. Exactly the same. Okay. Now, how do we tell that A and B is equal matrix? There, equal matrix A same as matrix B. So it means equal matrix. Okay, if you look at the element, so there are total 4 elements in matrix A. There are also 4 elements in matrix B. Yeah, so simple one. M equal to 7. N plus 1 equal to 6. N equal to 5. Then negative 10 equal to 2k. K equal to negative 5. Last one, 8 equal to 1 over 3h. So h equal to 24. Done. Very simple. No need tuition already. Equal matrix. Equal means exactly the same. So if exactly the same, then we can find out the constant, the variables. Okay, move on. Move on. So now we do the operation, plus and minus, addition and subtraction. Just now equal matrix, we have same order. We have equal, then it's exactly the same. For addition and subtraction, the order is also the same, but now we just do the normal operation, which is addition and subtraction. So if can, you don't use calculator. Let's see, can do not without calculator. So P plus Q here, P means matrix P, the group P, plus all the elements in group Q. So cara tulis, A. So because matrix is in the group, so we write all the elements in the group plus another matrix. Okay, write properly like this. Then we can add already. So when you add from left to right, so 9, negative 3, positive 3, 7, done. Okay, that's how we do the operation. So the matrix is always in a bracket form. So you can do this bracket or you can do, like set notation like this. Both also accepted. Both also accepted. So P minus Q, a quick one. P minus Q. So we just need to show out this group, matrix P minus matrix Q. So from left to right, 3 minus 6, that is 1 by 1, negative 3. Negative 7 minus 4, negative 11. Negative 7, then this is 9, counting. I think until now should be quite easy, right? So you can follow, everyone? Can follow or not? Yes, huh? Too easy, huh? Can. Okay, next. Okay, slowly we are going to level 2 already, just like you play game. Okay, yes, okay. Now level 2, multiplication. Before we go to multiplication, there we have a K again. It's just like chapter 1. What does it mean? K. Constant, multiple, gandaan, scalar. Scalar means like it increase how many times, berapa gandaan. So now if let's say we have a number outside of the matrix, it means it's a constant, a same rate. So you got to times in. Then you must be fair. Each element also you got to times in, distribute. So example here, you have a number 2 outside. So times in, you get 6. 2 times 7, 14. 2 times negative 4, negative 8. 2 times 2, 4. Okay, so just times in only. Times in. Okay, now this is a digit. A digit 2 means multiplied by 2 only. What if this is 1 over 2? Example, 1 over 2. I realized that a lot of students not really sure what is 1 over 2. Actually, 1 over 2 means divide. Divided by 2. 1 over 2 here means divided by 2. So if you want to find the elements inside the matrix, or divided by 2, so 4 divided by 2. So it should read as this. 4 divided by 2, 2. 8 divided by 2, 4. So this one cannot divide, cannot simplify. So 3 over 2. So we can write like this. 3 over 2 over 2 at the bottom. So negative 2. So once you times in, you will get the single matrix. Only one matrix with all the elements inside the matrix. Okay. So next, okay, then this is very, very important. Level 3 now. Level 1, level 2, now level 3. Multiplication. Okay, so just now we talked about plus and minus if the order is the same. 2 times 2, 2 times 2, then we can do the operation. Simple one from left to right. But multiplication of two matrices, now it's just like finding boyfriend and girlfriend already. You have to see ngam or not ngam first. Can become boyfriend or girlfriend or not. Okay, how to say that? You see, multiplication. Okay, don't look at the note first. Okay, so let's say now we have 1, 2, 3, 4. Then another matrix is 5, 6. For multiplication, it doesn't mean that the question asks you to do multiple, then you must do multiple. No, you got to check first. Okay, wait a moment. Wait. Let me check first. Can you multiply or cannot? You must have this kind of mindset. It's not the question asks you to do what, then you do what. You say, wait, let me check first. So how to check? You write down the order. C 2 times 2. 2 rows, 2 columns. Then the second matrix, 2 rows, 1 column. 2 times 1, right? 2 rows, 1 column. Okay, then can kawin or cannot kawin? Look at the number inside. Same character. Oh, you good, you good, nice person. I nice person. Okay, can. So when you kawin, okay, see, if can multiply, now you want to see the baby, the outcome. What is the outcome? So you have to take the number outside. Meaning, the outcome, the output now, will have the order 2 times 1. Meaning, 2 row and 1 column. 2 row and 1 column. So how many elements inside the matrix? Only got 2. Only got 2 like this. Okay. Once the matrix can be multiplied, now you can find the baby already. Okay, then we read the position. The position at here is the first row, row 1, column 1. Row 1, column 1. It means the elements in row 1 must multiply with the elements in column 1. So I have to write like this. See, 1 times 5 plus 2 times 6. One more time. 1 times 5 plus 2 times 6. Second baby here, read the position first. Second row, so row 2, column 1. Row 2, so all the elements at row 2, second row, multiplied with the elements in column 1. 3 times 5, like this, plus 4 times 6. Then you calculate. So 5 plus 12, 17, 15 and 24, 39. So this is the answer after multiplication. Okay, digest first because it's level 3 already. Okay, let me repeat again. So you can follow one more time. Okay, why we plus? Okay, and multiplication. Okay, when we do the multiplication, we have to sum up both multiplication. That's why we have to plus. Because we have 2 elements there. Okay, why can or cannot multiply? Okay, this example is it can be multiplied. This example is it can be multiplied. Now, let me show you another example which is not able to multiply one. Okay, I give you something like similar one like this. Okay, so again, not every matrix can be multiplied. Must understand. Not every matrix can be multiplied. You got to check the order first. So here, 2 times 2. The second matrix, you go to 1 row, 2 column, right? 1 times 2. This case cannot multiply because the number inside is different. It's different. Tak sama. Not same. So if it's not same, we cannot proceed. We cannot proceed already. You cannot do multiplication already. In this case, cannot multiply. One set column and other pair row must same as it. Yes, correct. You're right. So easy to remember, then the number inside, not the number inside. So this is 2 times 2. This is 2 times 1. This one because the number here same, then can multiply. So if can multiply, then only we multiply. Look at the difference. So okay. So first thing first, you got to check whether it can be multiplied or not. So you check the order first. After you check the order, you must know the order of the output after multiplication. What is the new order? Means here. Then only we do the multiplication. So you must follow the sequence. That's why I say Kawin got baby, like that. Okay, so just easy for memorizing. Okay, let's try another one. This one may be too hard at the moment. Okay, like this. First question, can these two matrices be multiplied or not? Can multiply or not? Can they Kawin or not? Must check the order first. Let's write down the order first. Horizontal, vertical. Rows, column. One row, three columns. This one, three rows and one column. Can, right? Yes, can, because the number inside, they are the same. 3 and 3. Okay, can. Then after that, how? What is the new order? What is the new order? Of the baby? 1 times 1 only, right? Yes, very good. 1 times 1 equal to 1 times 1. So one row, one column, meaning only got one baby. Only got one baby. So row 1, column 1, meaning you take all the numbers in the first row, multiplied with all the elements in the first column. So you will have only one answer. So 1 times 4 plus 2 times 5 plus 3 times 6. So it won't repeat. When you multiply, it won't repeat 1. So 1 times 4 plus 2 times 5 plus 3 times 6. Got the idea? This multiplication we have to do a lot because it's kind of confusing, right? So answer is 32. Okay, so 1 times 1 meaning you have only one element in the order, in the matrix. So now let's try another question here. So sometimes got 0, sometimes got negative, must be careful. Okay, this question, first step, we check first, can multiply or cannot multiply? Can or cannot? Same question. If it's 2 times 2, 2 times 2, so for sure can, right? Because 2 times 2, 2 times 2, it's a square matrix. Then the outcome also 2 times 2. 2 times 2 means 2 rows, 2 columns. So there are total 4 elements. Do you see? There are total 4 elements and the arrangement is goes like this. Okay. Next, we can do multiplication already. So we read, okay, we read out the position at the, for the first element first. Row 1, column 1. Meaning, take all the elements in the first row multiplied with the elements in first column. So if you can see the pattern is like a 7. Horizontal, vertical. Okay. 0 times 5, so I just write down the number. 0 times 5 plus negative 1 times 3. So that will be the answer for row 1, column 1. Here, second element, still first row, so row 1, column 2. So now, this vertical line, it goes here. First row, second column. So 0 times 2 plus -1 times 1. Third element, second row already. So row 2, column 1. So just now is a 7, a pattern 7, right? So now is L shape. L shape. Second row, column 1. So 4 times 5 plus 6 times 3. Last one. Row 2, column 2. L shape, ah? Then now this will change to second column. So 4 times 2, go up first, ah? 4 times 2 plus 6 times 1. Done. Then you can use calculator okay, to find out the outcome. No? Can follow? Everyone can follow or not? So this is the final answer. Is that okay? Hooray, yes, okay. So now you try one and then you give me your answer, okay? Is that okay? So we try another one. Then you let me have your answer. Question here. What about this? One get the answer. First, check whether can multiply or not. If yes, what is the new order of the output are? And private message me your answer. Okay, I have one answer here. So I think that is 1 times 1, right? What is that? Okay. Okay, so you have to make a habit. I think it should be like this. You have to make a habit, write down the order first. 1 times 2, 2 times 1, right? So this one cancel. When the number is the same, you have to cancel it. So that you are very clear that, oh, your output is only 1 times 1. 1 times 1 meaning you only have one element. You only have one element. So equal to, since only got one element, row 1 times column 1. So if you look at the number, it will be E11, E11 here, times E11. Then E12 times E21. Yeah, Nika correct, yeah, yes. So meaning 5 times 8 plus 7 times -3. Then you will get the answer is 19. Only one element. If you're not sure, you can do, okay, one row, one column. So you see the intersecting point, meaning you got only one element. That's how you check. Okay, so one more question. One more question. I have the questions last time here. No. One more. What about this one? So also can be multiplied, right? 2 times 1, 1 times 2. Same. That means can multiply. So the outcome will be 2 times 2. Can draw the line. 2 rows, 2 columns. So you will see the intersecting point is the elements. It's the baby. So got 4. Then you multiply. First one, row 1, column 1. Row 1, column 1. That's the answer. Multiply only. Row 1, column 1. Next, go to the second right side. Row 1, first row, column 2, right? First row, column 2. So 5 times 9. Third one, over here, second row, row 2, column 1. Row 2, column 1. The last one, row 2, column 2. Row 2, column 2. So you will have 2 times 2 as your output. So anyone has question on that? Not so sure on how to do the multiplication? So now you try some exercise before we move on. Now this part is very important because you will link to level 5 later. It's still multiplication. Still multiplication. Now let's try some exercise first. So start from this question. Okay. So it's given that matrix S, we have 4 elements there. So calculate the value of S11 plus S22. Simple question. So what's the answer? You can just key calculator and find the answer. S11 plus S22. C, okay, yep, correct. C, yep. So S11, S22, so just total up only. Okay. What about, okay, this one is equal matrix. So what is the value of H and of K if P equal to Q? P equal to Q means equal matrix, they are the same. So 2H plus 1 equal to 15. So if you want to write down in paper 2 as a working, so you just form the equation now. 2H equal to 14, H equal to 7. So next, 5H minus 8K equal to 31. So this is 5 times 7, 35. So 8K equal to 35 minus 31. So it will be 4, right? 4 equal to 8K. So K is 1 over 2. So got the answer lah. So equal matrix, this is how we check equal matrix. Okay, then what about the normal operation? Normal operation, plus and minus. You look at the order, it's the same, right? 2 times 2, 2 times 2. Okay, so just now multiplication, little explanation here. Now, how we know is multiplication or a normal addition or subtraction? Look at the symbol there. If in between the matrix got symbol, is either plus or minus, then it's a normal operational. So you just do normal operation. But if without, meaning there's no symbol. So the two brackets is together. So obviously this is multiplication. If there is a symbol in between, then it will be normal operational, plus and minus. Okay, so number 9, what's the answer? So if it's objective, we can just check out 7 minus negative 9. So cancellation method, it cannot be. Okay, then you find this one maybe. Negative 4 minus 6 is negative 10. So answer goes to T. Yeah, correct. Yes. So cancellation method. Okay. Mixed operation, plus and minus. From left to right only, same thing. 3 plus 5 minus 0 plus 3. Just try to avoid careless mistake we'll do. Just try to avoid careless mistake. So quick one, this one. What's the answer? straight away, okay, if you count from left to right, it's 11. So straight away you get the answer. Then the others no need to do already, because that's the answer. Okay. Mixed operations, okay, still mixed operation, but we have a scalar here, like the multiple. So you got to times in first, remember, you got to times in first, then only you do subtraction. So the outcome will be negative 15, 12, 3, negative 9, then minus. Okay, so yeah, get negative 17, cancellation method. So 12 minus 84, then 3 plus 3, 6. Is there possible multiply and addition in the same question? Seldom. Seldom. That means plus, minus, times, and divide. Very seldom. Don't worry. Not to worry. Yeah. Usually it will be something like this. Scalar, involving the scalar. Like this. So this question also same. Number 13 also the same. So you got to plus first, then multiply times in. So 2, let's say you want to find M only. Pandai-pandai. So we just start from the element E to 1. Meaning 5 plus 7 equal to 3 times n. You don't need to do all one because you want to find value of m only. So 5 plus 7 equal to 3m. Form equation, and then you can find the answer already. Oh, we are correct. Yes. Okay. So more or less, see 15. You know how to read 15, right? 7m means you have the matrix. M is the matrix. Minus this question, this matrix equal to 2 times in. Okay, so a quick one. So how to solve 15? Questions 15. Okay, you can rewrite. Move this is like the normal mathematics. Move to the back, then it becomes plus the whole matrix, right? Plus the whole matrix. So equal to times in belakang 6, negative 18, 14, negative 4, then plus the whole matrix. 7, negative 10, negative 3, then 3. You move all the matrix, the group to the back, so you plus the group. So 7m equal to, then total out only. Negative 28, 11, then this is negative 1. Okay, so what is the value of m? So m here 7 times n. 7 times 7. So move to the back, it will become divide, right? Remember how we write divide? 1 over 7. Divide, it will become 1 over 7. So with this matrix, so what's the answer? A, B, C, or D? Answer out already. 1 over 7 means divided by 7. Divided by 7. 13 divided by 7. See? Got it? See how to do or not? 7, change to the other side. Then it becomes 1 over 7 in fraction form. Fraction means divide. Yes, C. Yeah. C. Okay. Now, number 16 is normal operation or multiplication. How we decide? 16. Normal operation or is multiplication? Multiplication, right? Very good. Okay, it's multiplication because there is no symbol in between. No symbol in between. Okay, so first we check the order first. Then we can use cancellation method, right? 1 times 2. 2 times 2 can multiply. So the new output will be 1 row, 2 column. 1 row, 2 column. So the arrangement is like this, horizontal. So this cannot be, this cannot. Then we find the answer. Row 1, column 1. Row 1, column 1. Row 1, column 1. So just key calculator, -2 times 6 plus the second number, 4 times -5. Answer is A. So to get the second answer here, second element here, row 1, column 2. Row 1, column 2. -2 times -1 plus 4 times 3. So I just proceed. Okay. What about this one? 17. Is it multiplication? Is this multiplication? Yes, right. Yep. Because the two matrices is together. QP. QP means Q times P. So if you put together, so it's multiplication. So if you look at the order, is 2 times 2, 2 times 2. So of course, the output also 2 times 2. Okay, also 2 times 2. So you make it together first. So that we can see what times what. Okay. So if you can't remember, but you remember the pattern, right? 7. How to write 7? Horizontal, vertical. Horizontal, vertical. So meaning the first element, 3 times 4 plus -9 times -2. Okay, so what's the answer? A, B, C, D here. Oh, I write. Okay, wait. Q times P. So this one have to move to the back. This one have to move to the back. Because Q first, right? Change. Terbalik. Terbalik. Okay, because Q first, Q first, Q, then only P. Q, then only P. So the answer is different. So try this. What's the answer? A, B, C, or D? So you got the answer already. Yeah. So if you're not so sure, then you remember the pattern. Like 7. Yeah. So 4 times 3 plus 6 times -2. So you get 0. So the second one, still 7. First row, second column. 4 times -9 plus 6 times 1. So you get this. Is it better now for multiplication? Okay, so 2 more. Okay. So it's given that two matrices multiplied then equal to 8 and 2n. So calculate the values of P and N. So here we must know also these two matrices is multiplied. Okay, so check the order. 2 times 2, 2 times 1 can multiply. That's why the order, the new output is 2 times 1. So we read the first element, the position of the first element. Row 1, column 1. Row 1, column 1. So we form equation now. We form equation P times 7, 7P plus -5 times 4 equals to 8. So 7P minus 20 equal to 8. 28, so P is 4. Okay. Second element, row 2, column 1. Row 2, column 1. So form equation 2 times 7 plus 3 times 4 equal to 2n. So 14 plus 12 is 2n. So n is 13. Sometimes, okay, I think it's last year SPM paper. Okay, multiplication, they give you the 2, 4, ABCD totally different order. So that one is just to check your understanding on it. No need to multiply one. You just need to know what is the output of it. So far, so good? Is it doable? Yep, okay, great. Okay, great. Okay, so a quick one. We go back to what we have learned in chapter 2. Okay, so first thing first, what must we know? The order. Sorry, just now we emphasize the order. How many rows, how many columns, and then what is the position of each element, E11, E12. So E12, 12 means first row, second column. So it must be row, then only columns, cannot change the sequence. Horizontal, then only vertical. Yeah, rows, columns. Okay. Equal matrix. Okay, we learn equal matrix. If we have equal at the middle, that means we can find the unknown. Equal matrix, same order, we can do operation, normal operation, plus and minus. So we have a symbol in between to show us whether we want to plus or to minus. This is actually we call scalar. Okay, I don't say multiplication first. Scalar. Okay, like a scale. Okay, it's just like a scale. You multiply it, times it. Okay, gandaan. Okay, then the fraction must know is it means divide. Okay, divided by 2. Then only we goes to multiplication. Multiplication. So multiplication, you got to check whether it can be multiplied or not. Okay, can be multiplied or not. Then you have to find out the outcome. Yeah, the outcome or the output. Then only you do the multiplication. So sometimes I don't want to show you the notes because it's too wordy, too many words. If you understand, then it's better. So another example here, this matrix has what order? 1 times 3. Here, 3 times 1. Same number, cut. So when you have the new order is 1 times 1 means you only have one element. Okay, you only have one element. So you just take all the elements, multiply, then you sum up, plus. Okay. Now, who can tell me what is the error here? There's the error here. Who can spot the error, spot the mistake? No symbol. Very good. So when we want to write the answer, must have the symbol, the matrix form. Very good. Yes. If it's only negative form means wrong. Even though your answer calculation is correct, without the bracket means still wrong. So must be careful. Just like coordinate. Okay, leave your answer in coordinate form. So if you write just 4, -2, salah. Must insert the bracket. Okay, same thing here. So insert the bracket. Okay, one last for today is identity matrices. Okay, one last for today. identity matrices. Okay, so identity in normal number is just like 1. Number 1, 1. 5 times 1 equal to 5. Don't see that one first, huh? Okay. 5 times 1 is 5. 1 times 5 also equal to 5, right? Now, so here, number 1 is very powerful in digit. What times 1 also equal back to the original number, right? Now, in matrix form also, we got something like number 1. Okay, we call it identity matrices. So what you can see in the matrix is the diagonal is all with number 1. With number 1. Okay. Diagonal means like this. Now this identity matrix is also a square matrix in a square form. So it will goes to 1 times 1, 2 times 2, 3 times 3, or 4 times 4. It's in square form. Cannot be 1 times 2 or 3 times 1. Cannot. It must be a square matrix. So this is 2 times 2. So if it's 1 times 1, the identity matrix is 1, only one number. If it's 3 times 3, the identity matrix will be, the diagonal must be 1, other numbers filled with 0. See, like this. This is 3 times 3, identity matrix. It must be a square matrix, so it cannot 0, 1, 0, no. That one is 1 times 4 already. Unless you write 2 times 2 lah. It must be a square matrix, like this. 2 times 2, 1 times 1, or 3 times 3. Diagonal. So what is the function of this identity matrix? Okay, it is like normal one. So if you have matrix A multiplied with identity matrix, so it will back to the original matrix, matrix A. So example on the left, you see identity matrix. Okay, why identity matrix? Diagonal is 1, multiply with matrix B. So the answer is exactly matrix B. So it means if let's say you have identity matrix, we can do the shortcut already. We don't need to check 2 times 2 then this 2 times 2, then this 2 times 2, row 1, column 1. No need, because we understand already. Oh, this is identity matrix is 1. So if multiplied with the matrix, it back to the original one. It's just like shortcut. 5 times 1 is 5. 1 times 5 is also 5. So if it's identity matrix multiply with matrix B, so answer is matrix B. Got the idea? Simple only. This one is simple one. Just like number 1. Is that okay? Okay. All right. Okay, so that's thumb up. Okay. So example, if you look at the examples matrix C and matrix D here. Let's see the answer first. 0, 1, 1, 0 multiply with this, then equal to another matrix. So the questions asked is, okay, is matrix C an identity matrix? Is matrix C an identity matrix? Give your reason. Possible to come out not? This kind of questions. Can they give you that equation, then they ask, is matrix C an identity matrix? So if you look at the pattern, C, okay, this times this is not pegged to the same original matrix D, then matrix C is not an identity matrix. This is very simple, just answer like this. No, because the answer is not. Yes, okay, yeah, answer is correct. Yep, yes. It's not, okay, it's not identity matrix because it's not the same with the original matrix. Yep. Okay. So we can just write like this. CD is not equal back to C, or is not equal to D. Hence, this one should be D. C is not identity matrix. Just like that only. Okay. So I will send in this file later together with the past year, similar at the back. Don't need to do first because yeah, we have to do cannot do first for the past year. No, because we have to learn until inverse matrix first, then only can do the past. Okay, so for today class is only the basic first lah. Until level 3 only. Next lesson, then we'll move on to level 4 and level 5. So one more chapter, one more lesson, I think we can cover complete chapter 2 also in a very fast way. Okay, if no questions, then we stop here. Then I send you the notes and the short one. And we continue next week. Okay, welcome. See you next week.